we want to find cosine of B. So go to angle B. You need to know the definition of cosine. It is the ratio of the adjacent side to the hypotenuse, and then you simplify the fraction. So the adjacent side is 120, and the hypotenuse is 123, and that reduces to 40 over 41. Cotangent of angle B as well. You need to know that cotangent is adjacent over opposite. So the adjacent side to B is 120. And the opposite side to B is 27. And you can use your calculator to reduce the fraction. 40 over 9. So cosine of B is 40 over 41. Cotan of B is 40 over 49. And then in number 2, angle A is our reference angle. We want to find this ratio called secant. We need to know that that is hypotenuse over adjacent. It's the reciprocal of cosine. So you flip cosine's fraction. Hypotenuse, 68. Adjacent, 32. Use the calc to reduce the fraction, and you get 17 over 8. And then cosecant, the reciprocal of sine. So it'll be hypotenuse over opposite. Hypotenuse is still 68. The opposite side to A is 60. Reduce that fraction, and you get 17 over 15. So secant, 17 over 8. Cosecant, 17 over 15. You'll see later how we use these. There are a lot of instances in the real world in which a right triangle exists or can be drawn. Architecture. Later on, you will be calculating the heights of objects that are too tall for you to measure. We'll actually be going outside. You'll use just 2 pieces of information: how much your head is tilted and how far your feet are from the base of the object. Then you can use something called a clinometer and something to measure the distance on the ground, and you can calculate how tall the object is with what you're learning now. That's just one usage. Trig is one of the most highly used forms of mathematics. And if you're interested in physics, it's the math for you. That along with calculus. Okay, number 3, we want to find the sine of 60 degrees. Sure, we could use the calculator, but we want you to display your understanding without the calculator. So I gave you the hint here. Draw your 30, 60, 90, and 45, 45, 90 triangles. So another thing that we expect you to commit to memory, just makes you more fluent for more advanced problems that you'll encounter later. So I think we did this one yesterday, yeah? Sine of 60? Okay. So I'll review it then. You need to know that sine is opposite over hypotenuse. So it's going to be x root 3 over 2x. And then you simplify that fraction. The x's cancel, and you're left with the square root of 3 over 2. So in any right triangle that has a 60-degree angle, the ratio of the side opposite that 60-degree angle to the triangle's hypotenuse is always going to be the square root of 3 to 2. And for curiosity, you can examine what that number is. It's 0.86. So in other words, in a 30, 60, 90, the side opposite 60 degrees is 87% the length of the hypotenuse. And you'll see how that applies later. Right now you're waxing on and waxing off. Okay. Cosine of 30. Did we get to that one? Okay, so again, a review. 30 degrees is your angle of interest. You need to know that cosine is adjacent, in this case x root 3, over hypotenuse, 2x. Again, the x's cancel. And you're left with the square root of 3 over 2. As I believe I said yesterday, it is no coincidence that the cosine of 30 degrees is equal to the sine of 60 degrees. At the beginning of class, Dominique asked me about cofunctions. This is an example of cofunctions at work. The sine of 60 degrees is equal to the cosine, cofunctions of 30 degrees. What's the relationship between 60 and 30? Excuse me?
60 is twice as much.
True. What else?
Oh, there's like a number thing. 60 is opposite. Oh, yeah. 30 is opposite with x, but 60 is opposite with x 3.
Also true. It's something that we studied before. Okay. What do these angles add up to?
90.
Okay. Therefore, they are.
Right triangle. No.
Thank you. Therefore, the sine of an angle is equal to the cosine of. Its complement. Thank you. And how can I express that algebraically?
90 minus sine.
90 minus whatever the variable is. In this case, it's theta. This is called a cofunction relationship. At my old job as an electrical engineer, we had this waveform generator that only outputted cosine. So if you wanted a sine wave, you would have to know how to write it in terms of cosine. So we actually do use this stuff.
How do you put cosine to a wave?
You will learn soon, young Padawan.
Yeah, I don't know what that is.
Excuse me?
I don't understand what you do.
Oh. Okay. I will try my best to help you. It is no coincidence that the sine of 60 degrees is equal to the cosine of 30 degrees. Take a look at the triangle. Sine opposite over hypotenuse. Cosine from this vantage point, adjacent over hypotenuse. The fractions are the same. If you do some more exploration, you will find that the sine of an angle is going to be equal to the cosine of that angle's complement. So the sine of 45 degrees is equal to the cosine of 45 degrees. Exactly. The sine of 10 degrees is equal to the cosine of
80. No. That's
80
yes.
degrees. Okay. So sine and cosine are co-functions. Cosine, get it? Co-function. Secant and cosecant are co-functions. Tangent and cotangent are co-functions.
Write the calculator when you do cosecant.
These are the co-functions. Before somebody came up with this special word cosine, they would call this thing the sine of the angle's complement. And then they got shortened to cosine. Okay. Yesterday I gave you the story of sine, and then cosine came later.
Tangent?
Say again?
What about tangent?
What about tangent?
When that comes into play.
Not right now. I can only do so much. So, sine of 30 degrees, opposite over hypotenuse, 1 over 2x. Oh, sorry, this is x. So it's x over 2x. And then the x's cancel. And what does this simplify to? Just say it out loud. 1/2. Good. Any questions on using the 30, 60, 90 or the 45, 45, 90 to define trig functions of 30 degrees, 45 degrees, or 60 degrees?
Can you repeat what you just said? Sorry.
Yes. Any questions on finding the values of trig functions for 30 degrees, 45 degrees, or 60 degrees? Okay. It's going to be okay, Sue, I promise.
Would you ever be asked to do it with 90 degrees?
No, you're never asked to do it with 90 degrees. Well, I take that back. You will, but it's different, as you'll see later.
Okay.
All right. We'll continue to ask you now. We're on number 6. So, Terry, you were called at random. Tell me how to find cotangent of 45 degrees. Nope. So it's just something you have to commit to memory. Something that can help you is knowing that cotangent is the reciprocal of tangent. So try again. Tell me, what is tangent? Adjacent. Okay?
Yeah.
That we want you to know, Terry. So flip that fraction. What do you get? Yeah, when you do 1 over something, you just flip the fraction. It's the reciprocal. So this is the same thing as 1 times 1 over tangent of theta. So it's 1 times 1 over opposite over adjacent, which is 1 times 1 times the reciprocal of the denominator. So it's adjacent over opposite. But I wouldn't do all that work. Just memorize that when you're taking the reciprocal, just flip the fraction. Okay? So, please continue. We're trying to find the cotangent of 45 degrees. So I'll guide you along. What are the sides of this triangle?
Side of the triangle.
Yes, we have a 45, 45, 90. Please tell me how to label the sides.
X,
Mm-hmm. Okay. Now, can you find the cotangent of 45 degrees? No, x radical 2 is the hypotenuse. Cotangent never has anything to do with the hypotenuse.
X over X.
X over x. And what is that simplified to? Uh-huh. Okay. Next up, number 7. U and J, tell me how to find the tangent of 45 degrees. Okay, I've done that for you. Very good. Good. So 45 degrees, opposite side is x, adjacent side is x, and U and J, that reduces to 1. Any questions? Number 8. We want to find the secant of 30 degrees. Yes.
I was confused with the adjacent angle where we do x or x radical 2.
The adjacent angle, whether it's x or x radical 2. X radical 2 is never going to be an adjacent side. It's always the hypotenuse. All right. Nick, tell me how to find secant of 30 degrees, please.
The opposite hypotenuse over adjacent.
Very good. It's the reciprocal of cosine. Keep going.
So then it's 2x over x root 3.
2x over x root 3. Very good. 30 degrees is your angle of reference. Your hypotenuse is 2x. The adjacent side to 30 is x root 3. And Nick, that reduces to?
2, 3.
Good. So the x's cancel, and you're left with 2 divided by the square root of 3. There's an algebra rule of etiquette that says do not leave a radical in the denominator. So we will rationalize by multiplying top and bottom by root 3. That gets us with what Nick said is the final answer, 2 root 3 over 3. This is what we call the secant of 30 degrees. Yes, sir?
What's cosecant?
Cosecant of 30 degrees? Well, cosecant is hypotenuse over opposite.
Oh.
So 2x, and the side opposite 30 is x. That reduces to 2. Okay. Good. Hopefully this stuff is becoming easier for you as we do it. Be careful. The more you do something, the better you get at it. So choose the things that you do repeatedly wisely. Gabe, cosine of 60 degrees.
Okay. Take a triangle.
Word.
Is that right angle at? Bottom right?
Yep.
Yeah, alright. So it's going to be a 30, 60, 90.
Correct.
Where we at? This is cosine? So
Yes.
it would be
Yes.
adjacent over hypotenuse.
Good. Keep going.
So, in a 30, 60, 90, across from the 90 is x root 3.
False.
X root 2.
It's 2x.
Across from the 60 is x root 3,
Yep.
and then the bottom is x.
Good.
So it would be x root. It would be x over 2x? Or x
That is correct.
Yes.
Adjacent to the 60 is x. Hypotenuse is 2x. And please simplify that.
1/2.
1/2. Good. Follow-up question, Gabe. The cosine of 60 degrees is the same thing as the sine of?
30.
Very good. Okay, because sine is cosine's co-function, and 30 degrees is complementary with 60 degrees, or 30 degrees is 60 degrees' complement. Nakia.
What was the thing you said yesterday? For the last thing, not so before the
Cho, shakao.
Cow.
how do you spell that?
Show.
Cho, sha, cow.
They're
not?
They're for different things.
No.
This is-
For sine, cosine, tangent.
Trisha Cow is
This is for the reciprocal ones.
I didn't know that.
Yeah. But I would say very few people remember this. They just remember SOHCAHTOA, and then they remember who is whose reciprocal. If you want to use it, be my guest, though.
no boy.
Okay.
Show.
Moving on. Next random person is Val. Please help me find the cosecant of 45 degrees.
Okay, so based off of the triangle, it would be. Okay, which one?
Number 10, cosecant of 45 degrees.
Okay, it would be that or x radical over x.
Cosecant is hypotenuse over opposite, and that reduces to radical 2. Good. 11. Jessica, please tell me how to find secant of 45 degrees. Very good. Hypotenuse over adjacent. X radical 2 over x, which is radical 2. Please note that the secant of 45 degrees is equal to the cosecant of 45 degrees, because 45 degrees is its own complement. Next, Gabe, number 12. Help me find tan 60.
Tan 60. So, first you got your triangle.
Okay, we've done that.
Always, it's there. Yeah, there it is. Alright. The acronym goes TOA.
Yes?
So it's opposite over adjacent.
Opposite over adjacent.
Opposite 60 is x with 3.
Good.
And adjacent is x. So
Good.
3 over x.
Good.
So root 3 over 1, root 3.
Like a boss, Gabe, with dollar signs for S's. Any questions on that type of problem?
Okay, wait.
Yes!
I'm confused. It's not on this problem. It's on the SOHCAHTOA.
Tell me.
So the notes we took yesterday was like tangent, cotangent, sine, cosecant, secant, cosine. Which of those are for which?
So the TOA is sine, cosine, tangent.
Sine, cos.
Yeah, so is sine, cot is cotangent. I know, is cosine. It'll be
I think I had them mixed up.
Sine equals the ratio of the the opposite to the hypotenuse.
Sine, like
Sine,
like stop sign.
S-I-N.
opposite hypotenuse. Ka, cosine,
Part using fine.
adjacent hypotenuse. Toa, tangent, opposite over adjacent.
And then the other is the cow sine one.
Trisha Cow. Trying to remember this stuff.
These are the reciprocals. Cosecant is the ratio of hypotenuse to opposite in a right triangle. Secant is the ratio of hypotenuse to adjacent in a right triangle. Cotangent is the ratio of adjacent to opposite in a right triangle. This is cosine's reciprocal, except that it's not. It's sine's reciprocal. This is cosine's reciprocal. This is tangent's reciprocal. Moving on. 13. A random person is Celine. Please help me find the length of the third side of the right triangle, which in this case is the diagonal of this square.
It's a 45, 45
Very good.
and then the 6 through 5 represent x.
Nice.
So then the hypotenuse is x root 2.
Very good.
And then looking at 5, I multiplied 6 through 5 minus root 2.
Nice.
And then I got 6 through 5.
Very good. Easy. 45, 45, 90s are easy. We love them. Next, number 14. Write in terms of the cofunction of a complementary angle. Hopefully, you have some idea how to do this now. Nikki S. First, please tell me what is the cofunction of sine. Yes. What is sine's cofunction? Cosine. Yeah. Just put a CO in front of the word. That's it. Or strip the CO away, and then you found the cofunction. Now, second question is, the sine of 78 degrees is equal to the cosine of how many degrees, Nikki S? 12. And how do you know that?
Subtract it from 90.
Very good. Yes, this is an illustration of a cofunction relationship in trig. Bunch of relationships that we're going to study. This is one of them. You need to know how to find a cofunction of a function. Just put a CO in front of the word or take away the CO, and you found it. And then get the angle's complement. In this case, it's 12 degrees. Great thing about math is you can prove things to yourself. So if you're in degree mode on your calculator, you can do sine of 78, get a number, and then the cosine of 12. Nice. They're the same. Next random person is Nick. First tell me what is cosine's cofunction? Sine. So the angle will be 29. Very good. Easy. Jen, please tell me what is secant's cofunction? Okay. Chowan, what do you think is secant's cofunction? Good try. It does have a CO in front, but just put CO in front of secant, and then you'll get secant's cofunction. The key is the co part of the word. So to be clearer, we have this word secant. Put a co in front of the word, and then you have its cofunction. So cosecant is secant's cofunction, or it's the secant of the angle's complement. The CO is the key. Second question for you, Chowan. What angle do you think I put in here? 56. The angle's complement. Good. Now let's see. dig up the remaining pages. Yes. Success! Great success! Number 17, Nikki S. Tell me what is tangent's cofunction? Co.
So just minus the
Co.
90.
Well, first tell me, what is tangent's cofunction? Cotangent. And then do what you were saying.
And then you get A.
Yeah, because 90 minus 76 is 14. Next random person, Nikki B. Where I have a different type of problem now, but it's related to the same concept. I'll guide you through this. So, sine and cosine are cofunctions, right? So what do you know about the angles that correspond to them?
That they're complementary.
Yes. Tell me what you know about complementary angles. No. Try again. They add up to what? They add up to 90. Therefore, for this to be a true statement, A plus 3A must equal 90 degrees. Okay, so it requires you to understand what a cofunction relationship is. It's related to complementary angles.
So is that just like an equation?
Yes, and then you solve this one. So go ahead and solve that one.
So it's 4A equals 90.
Good?
And then you do divide by 4 on both sides. You get 22.5.
Good. That is the value of the variable A that will make this a true statement. Mathematics is about finding the truth. That's the value for which the sine of an angle is equivalent to cosine of triple that angle, 22.5. Okay? Sine of 22.5, bam. Cosine of 3 times 22.5, I'm the man. Algebra gives you this power. You don't have to like fiddle around with your calculator and do a bunch of like testing and stuff.
Wait, why'd you get like a decimal?
You get with certainty what the answer is. It's pretty awesome. Okay.
I have a question.
Question.
Do you solve for A and then circle B, or do you solve for 3A and then circle A?
You solve for A.
You solve for A,
And you're
the
done.
answer?
Yeah. Next random helper is Terry. We're on number 19. Or is he on a bagel?
No, no, it's a roll.
Okay, okay, all right.
Stand by that.
Okay, Terry, activate. Do you subtract theta plus 42? Oh no, you cannot. And the reason is because they are, what word to use? These things inside the parentheses, they are off limits to you. They are parameters of functions. They're inputs into functions. You have to let the function do its work first. But in this case, we can use knowledge about the relationship between secant and cosecant to get at what these are going to be, or at least what the relationship is. So, cosecant is secant's cofunction, which means that cosecant will be equivalent to secant when the corresponding angles are complementary. Well, let's do it algebraically. Yeah, this angle here and this angle here are complementary. So set up an equation using that knowledge. Good. This came to me as well. You could also do theta equals 90 minus this. You'll get the same thing. Okay? And Terry, I'm confident you can solve the algebra. So 2 theta plus 42 equals 90. So 48. 24. Okay?